Hi guys, it's Anu here again. Welcome to my channel. Today I'll be taking you through the basics of Simatic Manager, opening a new project, the process of creating your hardware configuration, and just basics of just playing around the software. This video is mainly for beginners and people that are new to the use of Simatic Manager. If you have any questions after going through the video, please leave a comment. Also like and subscribe for more videos. So straight to the reason for this video. I'll be going through the process of opening a new project. Typically, before you start your programming, you would have done a sketchwork of what your project should involve. So basically, you would have known the number of input and output modules you need, be it digital or analog input and output modules. You would also have an idea of the number of CPUs that will be in your project, also the number of interfaces you would need to have, be it whether it's interfacing with another machine or it's going to be a standalone machine. Also, you would also have an idea of the kind of communication protocol you would wish to use, be it industrial Ethernet or Profibus DP. When you have an idea of all this, you can then take your sketchwork, which is written down, and then try to go ahead to create a project. Typically, this is what a typical installation S7300 installation looks like. Like I said, I've said in previous videos, you have the S7300 and then the S7400. You also have 1200, 1500, but this is a typical S7300 panel. As you can see, you have your power supply, and then you have your CPU here, and then you have signal modules, so input and output modules. Your CPU has various LEDs that tell you the status of the CPU. Here you can see the run or stop. So you can either put your CPU in run or in stop mode using the switch. You can also do a memory set of your CPU memory using the same switch by long pressing on the switch. You also have various LEDs here. You have this, which is an SF. I'm not sure if you can see clearly, but this is actually SF, meaning a system fault. This is usually as a result of a programming error or a missing input module or input device. You also have something called the bus fault, which is usually due to a missing slave or a missing device. Now, all your modules have an identification at the top. Here you can either have, be it a signal module, or in this case you would see something called CPU written on it. There's also an order code at the bottom. Now this order code is important because you have to create exactly the same order code in your hardware configuration. Whatever you have physically installed on your machine has to tally with what you have installed on your hardware configuration in your program. If it doesn't tally, your program will not work. So usually at the bottom, you would see it written there. Now, for the example that I want to do, what I've decided to create, so like I said, what I have done is that I have written a list of modules that are physically installed on my machine, and I would be going through the step of creating them in my hardware configuration. So I would go here, File, and New Project Wizard. I'll go through this sample just because, of course, I'm assuming that people that are watching these are beginners. If you're more experienced, you might not need to go through the step 7 wizard. Now, this just explains to you what the step 7 wizard does, and just explains that you can create your project step by step. Anytime you create a new project in Simatic Manager, OB1 is automatically created. OB1 is your default cyclic execution operational block. And what happens is that when you download your program to a CPU, it automatically runs OB1 first. So it always goes through OB1. So whatever program you end up writing in the future within that project, you need to go back to OB1 to call that project, that FC or that function block, or that function block, or the function itself. If not, else it will not be executed. So I'll click on next. Now, it gives me the option of selecting what CPU that I need. Like I said, I already created the list that I want. Here I can see that I have a CPU module 3152 PNDP with this order code. So what I'm going to do now is I'm going to look for CPU 3152 PNDP, and I'll look for this other code 6ES73152EH140AB0, which is this one. So I'll select that. This just gives me various the various properties of the CPU. Now I would also change, it gives me the opportunity of changing my CPU name. You can leave it as the default name that it gives it, or you can decide to change it to master CPU, for instance. And the software automatically gives it an IP address, an MPI address of 2. Now your MPI address, your MPI address is your preferred address, and by default it usually gives it a value of 2. You can choose, however, to change the value. You can pick anything between 2 and 31 being the maximum address that you can give your CPU. I'll leave it as 2 because I really don't want to change it. Now, it then gives me the option of adding some blocks. Operational blocks are default blocks, like I said. OB1 will always be there. I cannot, if I deselect OB1, my program will most less likely not run. So I want OB1 to be present. I can then obviously select any other of these OBs. I'm more interested in the communication fault OB, as well as my programming OB, programming error OB, and a complete restart OB. Now, this programming error OB, what it does is having it in my program ensures that if at any point the CPU runs into a programming error, if at any point the CPU runs through my program and realizes that there is actually an error in what I have done or what I've programmed, rather than putting the CPU on stop mode, the CPU will automatically just go into system fault and continue running. The same thing applies for communication faults as well. So I'll just pick those two, and then I can choose to change my default language for my blocks. It can be STL, ladder, or FBD. Now for beginners, I would always suggest to just go with ladder because it's easy to understand. It's a lot visual, it's very visual, so you can easily understand your programs as well as gradually build your competence in programming. Now, if you're more advanced and you've probably programmed in other languages and you are very sound in programming, you can choose to go with the STL and then just learn as you go. Now you see all the OBs have been created here. Now I'll select next. It gives me the option of saving, changing the project name. So I'll just write project 1, or sorry, project 2, because project 1 is already taken in my S7 PROJ folder. So I'll just call it project 2, and then I would say finish. So what now happens is that the software runs through everything that I have selected and creates a project for me. This might take a while. No, it shouldn't take too long, maybe just a few seconds, depending on the speed of your computer. But mine probably take about 10-20 seconds before it finishes. And now it's done. So it opens my project for me. As you can see, I think, yeah, so it opens my project for me now. So this is what I have so far. If I change this to a detail view, I see my OB names and the symbolic names for the OBs. Now, going into the hardware configuration, I would come to my Simatic 300 station and click on hardware. When I click on this, you would see that because I already selected my CPU using the wizard, I already have a rack generated with my CPU already on position number 2. Position number 2 is always on your rack, is always reserved for your master CPU. It's always reserved for your CPU, no matter what. So you cannot put any other thing in this slot. You cannot move your CPU into another slot. It will not work. It will give you the alarm saying that you cannot put a CPU in this slot. It always goes in position number 2. Now, the rack, if I hadn't used the wizard, the rack wouldn't have been, this rack with the various slots wouldn't have been automatically created. I would have needed to come here under Simatic 300, go to rack 300 and then select a rack and drop it. So I'll just select and drop. So that's how to create a rack. So you see that another rack has been created. I don't need this though, so I'll just delete it and I'll continue what I'm doing. Now, like I said earlier, I already listed out a couple of modules that I want to have created. Now, to do this, I would need to come back here, come back to my hardware configuration. I will minimize this in a way so that I can see this as well as see my rack, my list. Now, slot number 1 is always for your power supply. You cannot put any other thing in there. So what I'll do is I'll go to PS 300, that's the power supply 300, and I would look for PS 307 10 amps, which is one of these three. So I'll look for the one that has the order code that I'm looking for, 1KA02. 1KA0, this is 1KA02. So I select it and I will drag. You see that when I try to put it anywhere else, it doesn't accept it. And I light slot 1 in green because that's the only place that I can put this power supply rack. So one power supply module. So once I put that in slot 1, it accepts it. Now, the next module I have put in my rack, automatically generated my rack, put in a power supply module, and there's already a CPU module in there. So I now need to put in my signal modules. Now, all these are signal modules, basically, be it digital input or digital output, analog input, analog output, they are all signal modules. Signal modules can take any space between slot 4 and slot 11. Slot 3, however, is always reserved for an interface module. Now, the interface module basically interfaces 2 or more racks. So what happens is if I have a master CPU with a lot of signal modules and I have some other signal modules that cannot fit into the slot, what I'll need to do then is I'll create another rack which might be within the same panel, physically within the same panel. I'll create another rack and then I will drop an interface module here on slot 3. So I'll just pick one of these two. Expansion rack. So I'll just pick one of this, just one of this for you. Just pick one of this. So I'll put that on slot number 3. Notice that it will accept it because that is only, it's only for that. Now, if I come here, it will tell me that I can only, this is interface module for send. So I need to pick 361, which is the receive. Because I picked just a send module, I can only use it in my first block. That is the one for the CPU. And then subsequent racks that only have signal modules would have to have the receive. And you see that I can only insert it in slot number 3 for that one as well. And you see that as soon as I put my interface module, it creates a connection between this rack and this other rack. If I had picked this one, it gives me dual functionality, meaning that I can use it as a send IM module or as a receive IM module. So I can use it on both racks. But because I picked a send and I now picked, and I can only use that one on the rack that has the CPU, while I use the receiver IM interface module on the rack that has all the other signal modules, and they can only stay on slot 3. As soon as you do that, you see that your CPU automatically creates a link between both of them. Your program automatically creates a link between both of them. So we'll discuss more about interface modules subsequently, but that's just the basic under the hardware configuration. I can also click on object properties and I see more properties about my IM module, just basics. Now, I'll go back to my signal modules now. Like I said, you can only put them from slot 4 and above. So I'll go to slot 4 now, and I need to have a digital input module. Now, I'll collapse this as well. So I can see I collapse this as well. So under my Simatic 300, I can see a signal SM300, all my signal modules here. Now I'm looking for the DI300, so that's digital input module. And I'm looking for the 32 by 24 volts. I'll then look for my specific order code, which is 1BL000AA, which is this one. I'll drop it here. That's one. But notice that I said I needed 2. So I'll drop another one on the next slot. Now, for you to understand something, all your signal modules have to have addresses configured to them. Your Simatic Manager automatically gives it addresses. If you look at this, the first one that I had has been given input addresses of 0 to 3. That means that bytes 0 to 3. Remember that it's a 32-bit digital input module. That means that 32 divided by 8 is 4 bytes. You can have up to 4 bytes on this module. So that's why it occupies addresses 0, 1, 2, and 3. The next one is also giving a default address of 427. Now, these are default addresses created by the program. If in your sketchwork you already have addresses that should be configured to this digital input module, what you just do is go here and then right click object properties and then select addresses and deselect the system default, and it then gives you the option of typing in a start address. Now I can choose to have my start address be from byte 100. I'll click OK in that case, and you see that the system automatically assigns 100 bytes 100 to 103 for that module. I'll do the same thing for the next one, although this time around I will start from bytes 104 because 103 is taken. So I'll start from 104 and I'll click enter. Now notice that the very first time I right clicked and I did object properties, you can also access that same menu by double clicking on it. It will take you there. So those are my digital input modules with their addresses already configured. I'll then go on to add my digital output module. Now in this case, I'll collapse this DI because I don't need it anymore and expand the digital output modules. Now I'm going to look for a 32 by DC 24 volts and 0.5 amps. I'll confirm that this order code is exactly the same. Remember, I said it at first. Your order code has to match what is physically on your device. So there must be no discrepancies. Now, the system automatically gives it an output address. In this case, it's giving an output address starting from 8. But I want my output address to start from 100 as well. So I'll just double click again, come to addresses, deselect system default, and select 100. So what will happen is that because it's a 32-bit module, it will occupy bytes 100, 101, 102, and 103, which you can see here. So now that I have done that, I have slotted in all my digital modules. Now I'm going to go into the analog module. Now I want an analog input module. I'll expand this, and now I'm looking for AI 8 by 16 bits. So AI 8 by 16 bits is this one. So what will happen now is I'll need to select the one that has exactly the same order code as this, which is 7F000AB0. So this is it. I'll pick that and drop that in slot number 7. Now again, I can edit the addresses that I want it to start from. At the moment, it's starting from a default address of byte 304. I'll leave it at this because I don't plan to edit that. Now, in this place, under the inputs, you can choose to configure each of the inputs. It's a 16-bit input, and each input 16 bits, and you can have up to, that's 2 bytes, and you can have up to 4 inputs in this. Now what happens in that case is that you can then choose to select whether it's a voltage input or whether it's current or it's deactivated. In the case of you have a 4-wire transducer where your input sensor is giving you its value in milliamps, you then select current 4-wire here, and then you select the 420 milliamps. Physically, you need to configure this port to actually reflect a 420 milliamp input, and then you can select OK. You can do the remaining 4 inputs, and then just select OK. Now, sorry, if I go back here, you see that I can enable a diagnostic interrupt and a hardware interrupt when limit is exceeded. So if I select this, what then happens is that it triggers this. It triggers an hardware interrupt anytime it exceeds, if for instance for channel, sorry, so that's 20.5 and 3.5, and this should be 10.5 and minus 10.5 minus 10.5. So what happens in that case is that when it sees any readings less than or greater than this, it will trigger the hardware interrupt. Now, for your analog output module, I'll collapse these analog inputs and then expand the analog output module, and I'll look for a 4x16 bit that has exactly the same order code as this 7ND000AB. This is it, so I'll drop that on slot number 8. So again, the PLC or the Simatic Manager gives it a default address of 320. In a case where I do not want to change that, I'll just leave it as that, and then I select OK. Now, if I go back to our other rack that, if you remember, we created an IM module for, I can drop modules in here. I can drop as many modules as I want in here, because now, because of this interface module, the CPU on this hand can communicate. Sorry, if I hide this, this CPU is able to communicate with these modules because of this input module. Now note that I cannot drop any other CPU here because there's just one CPU, so I'm not allowed to drop any other thing. So I can't drop any other CPU there, because for an interface module you have just one CPU, and an interface module combining 2 racks together. At this point, I can now save and compile my hardware configuration. It runs through it. If I was connected physically to a PLC, I can actually download it at this point and then monitor my program. Thanks for watching, guys. Do like, comment, and subscribe for more videos. If you have any questions, drop a comment down in the comment box and I'll make sure to answer as quickly as I can. Thank you.